Okay, so moving along. In the last video, we just kind of, without really going over what every piece of code is, just made sure we've got Visual Studio set up correctly and did a tiny little program called a Hello World. As I mentioned, Hello World is usually in most programming books the first program you'll write, and there's or some sort of equivalent or variant of that. So let's get rid of this line here, and I'm just going to continue working with the same example. So what I'm going to introduce now is the concept of variables. And what does a variable do? Well, you have to remember in programming, especially in C and C++, and when I say C, we're actually not technically doing C programming in this class, but C++ is what's known as a superset of C, and maybe not a proper superset, but a lot of the things that maybe you would see in a C programming class, you'd see in this class, and then there's slight variance for C++. So if I say C and C++, don't worry about it too much. We're going to be programming in C++ in this course, but we're not going to be using kind of the advanced things. But anyway, so variables are going to hold a piece of data, and in the context of mathematics, which historically a lot of the original programming came from, it's sort of similar, but there's slight differences. So in mathematics, you would have a variable that maybe could hold a bunch of states at the same time, but in programming it's a little different. It actually holds a finite piece of data. So the typical first data type is an integer. So I'm going to say int I, and then I'm going to say I equals 5, and then we'll say I equals build, start without debugging. Okay, so we can see, I don't know if you can see on the screen recording of this or not, but we see that I equals 5. Okay, and then I hit enter to continue, or really any key. So what exactly is this program now? So what happens is when I declare a variable, and that's what it's known as. When you write it at the beginning of the program, you're doing what is known as declaring a variable. Your program doesn't really know about any of your variables unless you tell it. There are certain languages where you can just start using variables out of thin air, and it kind of infers to make the variable exist. It knows that because of your intent of using it, that you must want it to also exist. C is not like that, nor is C++ or Java or many of these other programming languages. So it's something to be aware of. So what you have to do is you have to declare the variable. And when you declare a variable, you have to give it a type. And so, as I mentioned before, historically, programming languages were for doing mathematical calculations. So what you'll see is a lot of the basic data types are going to be some sort of number. So what is an int? An int is an integer, and it's going to be, and I'll write in the comment above here, it's going to be something like -5, 1, 0, 15, 9, some big number. Okay, so I hope that makes sense. So an integer is a non-decimal number, and there's actually a limit to that. You probably won't run into that limit, but when you hear people talk about 32 and 64-bit processors, that's what those limits are. So even though mathematically things might go to negative infinity and positive infinity, in a programming language, a computer can't really hold that many values. So even this large value of 99,000, that's not really an issue for a computer, because computers can work in numbers of billions and trillions. But just keep in mind, you may one day run into a limit on that. So that's what an integer is. It can be have a negative number, a 0, really any whole number that is in a decimal. So that's what we've gone and declared. And what that does is that makes inside the computer, inside of the computer memory, inside of the RAM specifically, and I should take a step back. What happens when you actually run your program? It takes it from the hard drive and what's known as the storage area. So for most of you, it's probably some sort of spinning hard drive. For some of you, it might be a solid state drive, and it actually takes that program and loads it into your RAM or memory. And from there, what happens is the individual instructions get sent to the CPU. And so in a typical system, you've got a lot of RAM. You've got many, many gigabytes of RAM. And on the typical processor, you've only got a few kilobytes. And the processor is very fast at processing those few kilobytes, but what happens is you go back and forth between your memory and your processor. So this program started, and then it read it from the hard drive and it loaded it into memory. And then what it also did was said, okay, I've got a variable I, and then I'm going to declare it, and I'm going to give it 64 bits of area on the processor, and then I'm going to set it to I equals 5. So inside your computer's memory somewhere, we've got I equals 5. And then so what we want to do from there is, and I should note, every single line here is an instruction, and these are executed sequentially. That's actually sent to your processor. So these execute one at a time. So by the time we get here, these two previous instructions have executed. So we know at this point in the program, I equals 5. So we go ahead and are going to print to the screen, and this C out, what it does is goes into that area of memory and looks for I, and it says, okay, I found a value for I, and I'm going to print that value. And so that's what you see on the screen. And if anybody's confused by that, I hope I didn't overcomplicate it. But I want to make sure everybody sort of understand what goes on when you're actually writing a program, so it's not this kind of super abstract thing that you don't exactly know what happens when you run a program. There's some pretty concrete steps that happen, and so I just wanted you guys to sort of know what those are. So that's what a variable is. Let's go ahead and declare another variable, one that's actually, we'll use float, and we'll say that f equals, and then on the second line we are going to okay, and I should mention regarding these names, so I've declared two variables here, and I've given them a name. I could have really given them almost any name. There's certain naming conventions. Typically you want to use letters and then some numbers sparingly, so we could, this technically would be a valid variable. When you, on a short program like this, you can use single letter names. Sometimes you'll get into a longer program, say a program that asks somebody for their age, and then you would typically actually call your variable name age. So, but in these short examples, we can get away with just using a single letter for a variable because the program's so short we know what it is. So again, as we did with that integer, we gave it a value, and then so when we run this, we're going to see that I still equals 5 and f equals 3.123. And so you kind of understand what happens with program execution, that it's executing one at a time. Say we assign it a value and then assign it another value. So as this program executes, it's going to take this first value and then it's going to take the second value. So by the time we get to here, it's actually going to equal 5.2 and not our original 3.123, because what happened is this instruction executed and it put that value inside of your computer's memory, and then the same area of memory was then overwritten by this next value. So by the time this instruction executed, it had that new value. So you use variables in programs a lot. It's a pretty core concept. When you take in and we'll go over this in a little bit, a value from a user. So as I mentioned before, is if you say your program takes a person's age, you'd store that in a variable because you don't know that person's age at the time. And sometimes what you'll even do is store a value inside of a variable just because you can give a variable a name, and so it becomes more readable. So say I wanted to store pi, which is approximated 3.14. Instead of using 3.14 in all my programs, which may not make sense as somebody else is reading my programs, what you can do is assign a variable to it, and it makes it a lot more readable. If somebody sees the word pi, pi, in your program, that will, okay, they must be referring to pi rather than just a number. And there's a lot of examples of that, but pi is probably the simplest for everybody to understand. So if anybody has any, they're a little shaky on variables, go ahead and send me an email or post a comment or something like that, and you can tell me the areas of variables that you don't understand, and I'll either answer it directly, or if it's a complex enough question, I may just post another video.